So I'm waiting for it. I'm going live. Okay. Hello, everyone. Welcome to Corda Token HTK workshop. I'm Irina, and I will be your presenter today with Ashutosh. So I'm waiting for it. I'm going live. Okay. Hello, everyone. Welcome to Corda Token HTK workshop. I'm Irina, and I will be your So what is token? A token is a presentation of an asset. In real world, a physical token is like a ticket. You go to a coat check, you hand your jacket, and the concierge gives you a token representing your jacket. And you better not to lose it. If you do, you're going to go through the talks. Is it yours or is it not yours? So this is actually shows one of the benefits of digital tokens. So what are the digital tokens? It's a very large amount of you will say that this is a cryptocurrency. True, some cryptocurrencies are subsets of digital tokens. And digital tokens also include tokenized assets. For example, Alice can tokenize her house. Then she has a digital token that represents her house, which is now a tokenized asset. And she issued, for example, 100 tokens. She can issue any number for the house that costs, let's say, £1 million. That gives an opportunity to anyone to invest in Alice's house by buying those tokens that represent part of your house. Let's say Bob buys a token from her and pays 1/100 of the value of the underlying asset. So this will be £10,000. For Alice, this token is liability. So meaning that something that Alice owns to Bob. But for Bob, this token is an asset. He can always go to Alice and redeem the token for the price of underlying asset at that moment. Let's go forward 10 years. Alice's house costs 10 million. So Bob wants to redeem his token. An underlying asset now 10 times more expensive than it was when Bob bought it. Alice gives him 1/100 of part of the value of the house, which is now £100,000. So Bob made £90,000 as a profit. So analogy to tokenization is issuing shares of a company on a stock exchange. So, but here you have opportunity to issue your own tokens, avoiding stock exchange. And you don't have to have like $1 billion company. Tokenization provides you finer granularity of your assets. Tokenization is an asset of an asset is a new operation. Another example is a piece of art, which you really like, but you can't buy it because it's too expensive. But you want to have some ownership of it. So here's the tokenization is coming into the picture. So all these examples are conceptual. Very few has been implemented so far. One of them is SDE, Swiss Digital Exchange, that uses digital tokens. Let's go to the next slide. So tokens are not a cryptocurrency. Some cryptocurrencies are subsets of tokens. So token is a digital representation of asset or ownership. And if we go back to our example when Alice issued the tokens, so for her, this is a liability. And for Bob, it's an asset. So what are we offering here? We are offering a tokenized economy on a blockchain, which provides a maximum security over your assets, whether it is physical or digital. The peer-to-peer transaction of a decentralized network provides the high security over your asset. Security is not very high when you transact in centralized network, since if a central network is hacked, It doesn't matter if you transact with the tokens or with an asset, your tokens or actual asset is still compromised. But for decentralized database, you can't really erase the token since the peer that involved in the transaction has a copyright. Even if one of the database is compromised, the other database is still secure. The probability to hack all these databases is extremely low, since it's very hard to know which databases have it, and hack all of them at the same time is practically impossible. So we are doing it in a decentralized network, which means that there is no single point of failure. Even when one of the databases is compromised, your tokens still exist in other databases. So it's very unlikely that all of the databases will be hacked at once. It's easy to trace since the immutable characteristics and provenance tracing feature of a blockchain allow the users to retrieve the credible story of the asset. And if you transact with the token, you are not really revealing sensitive information of your underlying asset. So there is no way it can be hacked. And all data lives in Corda ledger and the entire history maintains there. It's immutable. You can't change it. And when you do transactions, all involved parties get the entire history of that state on the ledger. It also increases liquidity and additional market access. So you can tokenize illiquid assets, increasing its liquidity via partial ownership. People can now afford, which they couldn't afford before, and this so it can help them to get into market access via this partial ownership. So we discussed what tokens are and why we need them. Let's see what tokenized decay offers. So tokenized decay provides a standard library to create and manage tokens in Corda. When I say create, I mean create an underlying asset type, which is a token type, issue a new token, move tokens between parties, and then redeem is the final step after which you want to redeem your token for underlying asset value at the moment. And tokenized decay contains two jars. So it's token contracts, which contains contracts, and workflows that contains all library functionality that help to build a code quicker for developers. And also it contains money library, which is digital representation of crypto and fiat currencies. And these components that make it easier for you to create token types for any fiat or cryptocurrencies. So when we talk of functionality of how to create a token type, there are two different categories of underlying asset that you can that can be fixed or evolvable that you can create. So fixed token type remain constant. All the attributes of this type remain constant and doesn't change over time. It's like a currency. £1 will always be equals to 100 cents. All attributes of fixed tokens are constant, and you cannot add or delete attributes. So from a developer perspective, it means that all attributes and properties are constant, and you cannot change them. For evolvable token type, which have the tendency to change over time, for example, if you have a car and you want to change the tires, so this is evolvable. Any asset that can be changed is evolvable. And here it means that all values or all attributes and properties of the class are not constant. And you can also add or delete attributes. And now fungible and non-fungible. So fungible means that the ability of an asset to be interchanged for other asset of the same type. Fungibility implies equal value between the assets. For example, a fungible asset is money. If Alice lends Bob a £50 note, it doesn't matter to Alice if she gets repaid with the same or with a different £50 note, as it's mutually it's possible to change them. So in the same sense, Alice can be repaid with 2 notes of £20 and 1 note of £10, since its total equals £50. But in the same example of non-fungibility, if Alice lends to Bob her car, it's not acceptable for Bob to return a different car, even if it's the same model and the same make of the original car that Alice lent to him. Cars are not fungible with respect to ownership, but the petrol that powers cars is fungible. So it's very the line between fungibility and non-fungibility is very thin. For example, gold is generally considered a fungible, since 1 gram of gold equivalent to another gram of gold. Though, but sometimes, in some cases, it's not. So let's look at how we have token types hierarchy in token SDK. So again, fixed token is means that all attributes and properties are constant, and we cannot add or delete attributes, while for evolvable token, we can change values of attributes, or we can add or delete attributes. So with the fixed token, we simply just create a token type object. Since the attributes of token type are fixed, you cannot change any of them afterwards. With the evolvable token type, it's a little bit more complicated. You would need to create a separate Corda state to store all the evolvable attributes. And because these attributes change over time, it's not practical to change those attributes for every token that belongs to different token holders. For example, when Alice sold her token to Bob, she doesn't need to go and change attributes in his token if she, for example, 3 years later decides to change a Windows or something. So what we do instead here, we create a token pointer, and that points to the evolvable token object, token type. But token pointer is fixed. It always points to the same token. But attributes of evolvable token can be changed. And no token holders need to change anything on their side. So for evolvable token, since we can change any attributes, we would like to keep a history of all changes. And that's why it has to be contract state. And so we can maintain the history on the ledger. And linear state means that evolvable token type can only be non-fungible since the attribute change over time. We can't create fungible assets. And while fixed token type doesn't change its attribute, it can be directly embedded into token. So you don't need to maintain it on the ledger because it never changes. Also want to show you that token type, token pointer, and evolvable token type are lives in token SDK, while states and tokenizable asset info lives in Corda core. So far, we've been creating token types, but let's issue them. So as you remember, we have fungible and non-fungible. Fungible means that that two equal values between the assets. So 2 £50 notes are the same, and you can interchange them, while non-fungible doesn't have this equal value between the assets. So houses are not fungible with respect to ownership. So token type, if we have token type is a bound, but your bound token is fungible, and the same for house. Token type is a house which is evolvable, and issue token is non-fungible. So all of them implements abstract token, which is a contract state. So now we are moving to token SDKs in build flows. So we can, as we saw that we can create tokens, we can issue tokens. When we create token types, issue token of particular token type. Then we can move tokens between, so Alice can sell her token to Bob, and then 10 years later, Bob uses redeem functionality to redeem the token from the underlying asset. And also update. It's only update, you can only update evolvable token since the attributes are not constant. And on fixed, you can't do any updates. Okay, Ashutosh?
Yeah, thank you, Irina. That was a very good explanation of the entire token SDK stuff. Hello guys, I am Ashutosh, and I'm also part of the same developer team, which Irina belongs to. So I'll be taking you through some of the code here. So just before that, before I talk about the code, just running through the slide all over again. So we talked about different things in token SDK, right? We talked about creating the underlying type. We talked about issuing tokens. We talked about moving and redeeming tokens, which didn't really talk much, but yes, I'll talk about that while I show you the code. And so you don't have to worry too much about. Okay, let me just share my screen while I can show you the code. Okay. Here you go. Yeah. Yeah. So, so what I was telling is we talked about all these things, right? And when we talk about creating, issuing, moving, redeeming, or doing any of these actions on related to tokens, we don't really need to worry too much about what's the entire workflow that we have to run through. So all of these is all the hard work is done for you. You don't have to worry about that. All of these, like if you want to create a token or a token type, basically you have create evolvable token. So generally you just basically call that workflow, and it'll do all the stuff that is required to be done in the background for you. So let's have a look at the code, and then we can revisit this so that it makes more sense to you guys. Yeah. So we'll talk about creating token types first. Before that, I want to stress on this point that token type is a completely different thing from a token. Token type is the underlying asset, which means it's the thing which you are tokenizing. When you say you are tokenizing a house, the underlying asset is your house, and then you issue tokens on top of that. So when we talked about token type, the token type is the house, and when we talked about fungible and non-fungible tokens, that's what the issued tokens which are issued on the house. So you will be holding some tokens, which is like the tokens which are issued for the house, and then those tokens will be a representation of the house, probably maybe a partial ownership or maybe a complete ownership. It depends on the actual use case of that particular utilization of token. But yeah, to be able to issue tokens, you need some token type. So it could be either fixed or it could be evolvable. So if it's fixed, it like we showed you in that hierarchy diagram, it has to implement or it has to be a type or subtype of the token type. So basically, it has to be a token type, which I can show you here, right? So and if it relates to something like currency or something like or even if you want to build some cryptocurrency, like you want to tokenize Bitcoin, we have sort of some of the groundwork done for you. We have some of the structural things that are already done. So we have something called as a money utilities, which has come out in token 1.2. These things weren't available in token 1.0 and 1.1. So you had to do something. It was available as part of token money, which was a separate CorDapp, which is now merged into token workflow. But then the way of creating it was different. Now things have become a lot more easier, intuitive. All you have to do is say token utilities or money utilities dot get USD or got GBP, get Euro, and all these things. All these kind of these standards will be imported for you, and you could get a token type for that particular currency. Right, but this is for something which is already inbuilt in the system or in the token SDK. What if you want to create something on your own? So for example, if I want to create a token which is on my name, let's say Ashutosh, right? So I would do something like this. I would just create a class of type token type, and I'll pass in the identifier, which could be Ashu coin or whatever, Arena coin, or whatever basically we want, or your own name or whatever you want it to have. And then you pass in a fractional digit. Now the fractional digit, as we discussed, is actually the denomination of the token. So if it's pounds, so basically for a pound, it would be the fractional digit would be 2, because 10 penny is, or 100 penny is equal to 1 pound, or whatever you say it in UK. So basically that's what it is. That's what the fraction digit are, right? So let's just concentrate back on utilizing something which is already available. I'm not creating my own coin here. Well, yeah, that's how you create a fixed token. Now coming to the evolvable token, this is a little different. Fixed token, like we already said, is fixed, doesn't change over time. 10 pounds will always be 10 pounds no matter what, right? The properties of that 10 pound are never going to be changed. It's going to be issued by the same authority. It would have the same value. But evolvable things like vehicles and something like houses, these things are going to change. So if you take an example of a house, so basically when you issue a token type for a house, there are a lot of things in that particular token type, in that vehicle type, could change. You could repaint that vehicle so it was red, and suddenly someday it might be a green vehicle, right? And then you could change the tires, you could change the seat covers or something. A lot of things that could change in a vehicle. So these things evolve over time, right? So when these things evolve over time, we have to have a way of maintaining those change, right? So that's why they are. If you have seen that diagram properly, it's basically a subtype of contract state, right? So they are actually states which are issued onto the ledger. So first thing that you do, just like issuing any state on the ledger, you create an instance of that particular thing. So for this particular example, it's a house state. Let's just quickly look at how the house states look like. We extend the evolvable token type. Pretty simple. That's a subtype of our of the linear state, which is again a subtype, or which again extends the contract state. So it becomes a state in Corda. So whenever you create this particular thing, few things that you need to understand is we have maintainers. So in a evolvable token type, it's maintainers. It's not participants for a general contract state. In a general state, we call it participants, but here we call it as maintainers. So it's pretty much similar to how the participants work. Instead of get participants, you say get maintainers, and this should return a list of all the participants who should know about this particular state or this particular token type in this case. And the other things that it will have is the normal properties of that particular evolvable token type. So for a house, it could be something like valuation. That's just a random thing which we have added up because we want this thing to evolve over time. So we have added something like a valuation which will change over time. Then you have number of bedrooms, you have construction area, any additional info that you want to put in. You might have an address. So all these are normal facts which you would like to include in your evolvable token type. Right. Other things are pretty similar. Nothing changes from the point of view of looking at it from a contract state, how a contract state looks like. And then coming to how we are going to issue this or create this token type. The first thing we do is create the instance, and then we create or we wrap this with a transaction state. So if you remember the normal transaction builder, it has multiple different ways of adding an output state, right? One of them is to directly add a transaction state, and it also has functions to basically add a, a contract state directly. But just to understand what a transaction state is, well, the transaction state itself is just a wrapper around the contract state, and it has certain few more metadata, I would say, something like the notary, the type of constraint it uses, and few other metadata which is required for the transaction. So the way you create this particular evolvable token type is just call the create evolvable tokens workflow, which is available as part of the token SDK, and pass in this contract or this transaction state, and that's it. You don't have to worry about what would happen in the background. You don't have to worry about whom this particular token should go to, how you would verify the contract and all those things, the signing and stuff. All those will be taken care in the background by the create evolvable token flow. So it's pretty simple. To create it, just call the create evolvable token, create an instance of it, and call the create evolvable token. And that's how you create your token. This would basically issue the evolvable token type onto the ledger. Yeah, that's it on the from the create front. That's how you create fixed and evolvable both. Now let's move on to issuing tokens. To do that, I'll just look at a different example. So this has all the different things that we might want to look at. So it has the create and issue as well. But since I wanted to show you how to create since I wanted to show you how to create your evolvable as well as fixed tokens, that's why I referred to a different sample. But yeah, let's move on and continue with this one. Create is pretty much simple. It's doing the same thing. We are creating a transaction state using the create evolvable token again to just basically create the token. Coming to issuance, so people who have come from token 1.0 and 1.1 might remember that issuance was a little bit of a pain in those versions. So things have been made a lot easier in token 1.2. There's something which was issued just days ago, like yesterday or the day before yesterday. So just if you haven't taken a look at it, so this is the right time to take a look at it after you have gone through this session. Well, yeah. So just to talk about issuance, so we have added 2 new token builders or builders. So just like transaction builder, we have token builders. So one is a fungible token builder and the other is a non-fungible token builder. Now let's look at fungible token builder first, and then we'll take a look at non-fungible token builder. So fungible token builder, as the name suggests, is used to create a fungible token. And earlier you had to do what you had to do is create the issue type and then pass it on to the constructor of a fungible token, which itself was a little bit tough or I would say complicated to do. But we have addressed that particular problem, and it's a lot easier. So use the token builder and just pass in all the information that it needs. So what does a fungible token need? It needs a token type, right? So it's an evolvable token. We talked about the token pointer when we had a look at the hierarchy. Now, evolvable token changes over time, so you can't directly inline it or embed it inside the fungible token. So we use a pointer to point to the evolvable token, so that each time the evolvable token changes, anyone who is holding that token doesn't have to worry about. So those people holding these tokens, we don't have to update those instances of the issued tokens basically. So that's why we are pointing, we are referring to the token type of the evolvable of an evolvable token via a token pointer rather than directly embedding it onto the fungible token or non-fungible token, whatever is issued for that particular evolvable token type. And then what we need is the issuer. It's get identity, as you could easily imagine or identify that whoever is issuing this, whoever is calling this issue flow will be the issuer. So get our identity, and then the holder to whom we are issuing this, that's the holder. And the amount or the quantity that we want this token to issue. Since it's fungible, it needs to have a quantity. And then finally call the build fungible token method, and that will create a fungible token instance for you, right? That's just creating it. Now we want to send it to the holder. So for that we need to. So generally you would have to just sign that particular. So fungible token is also a state, right? So to send it across to someone who to do that particular transaction, you have to just do all the template steps which are required in Corda, right? You have to sign it, you have to verify the contract, and then you have to just call the finality flow and send it over to whoever should be knowing about that token. But we don't have to do all that. It's just you just call the issue tokens, pass in the fungible token instance, and that's it. And it'll take care of everything in the background. It will just it will sign it. It will basically verify the contract. It will collect any signatures if required, and then finally it will do your it will basically send it to the holder. Well, that's how you issue your token. And so once I'll just have a look at the non-fungible builder that's over here. This is the fungible, and yeah, here you go. The non-fungible builder is pretty much similar to the fungible builder. Nothing extra that we do here. So what we do is just create the non-fungible builder instance and pass in all the information. The only thing that's missing here is your amount. As you can easily imagine, we don't have an amount in a non-fungible token because it's non-fungible and it's unique in its own term. It cannot have an amount, right? So that's why no amount, but yeah, you have a token type, you have an issuer, you have a holder, and that will create a non-fungible token for you. That's from the issuance. And to issue it is pretty simple. Just call the issue tokens, right? Just like we did for the fungible one. Next, we move on to move. Why do we need a move, right? So move is where we want to trade this token. So I'm holding some tokens, and then probably just I want to send it to someone. Probably I want to trade it on an exchange, or I want to send it to a friend, or whatever I want to. I want to send that the tokens, a part of the token or all of them that I'm holding, to somebody else. So to do that, I use the move tokens move token flow. So there are two of them, either move fungible token or move non-fungible token. Depending on the type of your issued token, you use that particular method or that particular workflow. It's pretty simple. Just call it just call the method just call the workflow, and it takes the amount and the holder as a parameter. Now amount is again this is a class of Corda code. I think this has nothing to do with our with the token SDK. This is again the same amount which we use in the normal Corda codes. So basically, the amount is the quantity, and then the type of whatever you're trying to issue. So for this case, it's the token type. Now again, our fungible house token is an evolvable one. So to get the token type, we don't really have a token type. We have to point it by a pointer. So just call the two-pointer method, and that will give you a type of token type, and that's what your amount class would represent. And then you can just pass in onto the move fungible token with the holder, and that will do everything else in the background. So similar things, all your signing, your verification and stuff, all of them will be taken care of by the flow itself, and you don't have to care about that. All right. Now, last thing is redemption. So the entire life cycle of a token would be something like you issue it, and then you move around that, and then you move around the token, and finally, at some point, you would redeem it, which means you would go back to the issuer and you ask for whatever that particular token particular token represents. Like, so we would redeem it in exchange of either part of or the whole of the underlying thing that it represents. So that's where you do a redemption, and in the process what happens is your token, it gets destroyed. So it gets burnt, right? So you burn out that token, and then you take back whatever is basically that token represents. That's what redemption means. And the way you do it is just called the redeem fungible or non-fungible token flow. And it's pretty similar to how you call the move fungible or non-fungible token workflows. you just pass the amount, and in this case, instead of passing the holder, you pass the issuer. So we need to know who has issued it, so that it could be burnt accordingly, right? That's how this works. So before we move to the slides, let me just show you a small demo of how these things. How I'll just show or try to run this particular sample and show you that how these things work, and you get a good idea of how tokenization really work on Corda, right? So let me just go ahead and run. I've already run the deploy node so that we don't spend time on that. I'll just go ahead and run the nodes. And to do that, I'll do a build nodes and run nodes. And that should bring up the nodes. I should have 4 nodes basically. I have the notary, I have the seller, and I have the buyer. Okay, I'm missing one node, which should be a friend. I'll talk about these nodes when we try to run this sample. Okay. So I just need to bring up one more node. Okay. Yeah, there you go. Here is this is the command that I could use to bring up my friend node. Yep. All right. So 3 of my nodes are up, and one is coming up, and that's all right. I can start with the seller. I'm not worried about the friend as of now. So what I'll do is, instead of typing on all the commands on the terminal, I'll rather fire up the node explorer, so that we can have a visual thing. We can visually see what's happening, right? It's a lot easier. So let me just log in to the seller. Yep. So the username and password are always user1 and test, like for all of our samples. So I'm logged into the seller node, and if I go to transactions, these are all the different flows that we talked about, right? We talked about the create, we talked about issue, we talked about move, and we talked about redeem. So these are the 4 things that we are going to talk about. I'm going to try to run now. First thing that we want to do is issue or create the underlying type, right? So whenever you want to issue something, you need to have the underlying type. So if you want to issue a house, you need to have a house to do a tokenization on that. So for this case, it is a house. Let's say let me give it an identification, which we call it a symbol. So let's say it's HSE, so that I can refer to it with the name of an HSE. Since it's evolvable, we're just typing in some valuation. Doesn't matter what valuation you type in. For the sake of this example, I'm just going with 10K, and then just execute this. And you see the transaction is successful, and I should have a token type or an evolvable token type issued on the ledger, right? So that you could see that there is an output of this transaction. And I could also validate that here, and you could see that my vault contains one state, which is unconsumed. And that state is basically a fungible house token, right? All right. Now, once I have the token type, I'm ready to issue tokens on this token type. So it's more like someone has this house and he's tokenizing the house and selling the tokens to someone. So when I say I want to issue it, I have it has to go to someone who is a buyer, right? So what's the symbol? The symbol is HSE, which is the identification which I talked about. And then quantity here is the amount of token that I want to issue. Remember that this is fungible, so it will have an amount, and let's say it's 1,000 for this case. And then the holder. And who is the holder here? We're selling the house, so we are tokenizing it and selling the tokens to someone. So the buyer is the one who is buying it. Just execute. And there you go. This transaction is successful. And you could see that it's an issue command. And again, what we have as an output is 1,000 tokens of type fungible. An underlying type is fungible house token, who is the holder. The holder is the buyer. But if you go to the vault, you don't really see the token because because it's the seller is not really holding it right now, right? So the token is actually with the buyer. So to see the token, let's just log out of the seller and log in to the buyer. Localhost. Let me just check what's the port for the buyer, and it is 10,009. 10,009. Username and password would be the same. It's user1 and one and test this queue. All right, we are in the buyer's node. Going back to the transaction, you see the same information, but in the vault you have an extra thing, which is the token, right? It's a fungible token, and it has been issued. This guy is able. This is the holder. The holder is the buyer. He's holding this token. And another thing that you might see here is the fungible token, fungible house token state, which is the underlying type or the token type. You would see that it's non-relevant while the token is relevant, right? The difference is that this guy is not a participant. The buyer is not a participant in the token type. So he's not a maintainer. If you see here, the seller is the maintainer. So he's not a participant in this, but he knows about it. That's where it's irrelevant to him, but still he shared. This has been shared. So in Corda, whenever there is a state which is shared with you and you are not a participant in that state, then the status of that state for you is non-relevant. So you won't be able to spend this subject to contract rules, obviously, but you won't be able to spend this normally. Okay, so we have a token type and we have issued certain tokens. Now comes the friend node, which we talked about. I think you should be up by now. Let me just revalidate. Yep, perfect. The friend node is up, and so let's say I want to gift some of the tokens that I have, the 1,000 tokens. I want to gift it to a friend. So that's where the friend node, right? So how do I do that? I can move the tokens. I can go to move. And just before that, it's not required that you go to the vault view, but if you are vault view to view the amount of token that you hold, we also have, if you go to the code, we also have another flow called the query token. And what it's doing, it's using a query utilities, which is again part of the token SDK, and that it has certain queries, certain different type of queries that you could use to basically get the balance of a token or something like that. So we are using the token balance query here to find out the balance of a particular token type. And going back in here, I just need to pass in the symbol, which was the identification that we use. So if it's HSE, and you get a message from the flow saying that you own 100 HSE tokens, or 1,000 HSE tokens for that matter. Well, yeah, so let's do the move now. All right, I'm going to move. Symbol again is the HSE. And whom do we want to be the holder? It's our friend. And we have the quantity field. I have 1,000, so let me try to send 600 to my friend and say execute. Yep, the flow is successful. And you can see that I had 1,000 and then 600 was basically passed on to friend. So 600 is held by friend now, while I hold 400, which was returned to me as a change, right? So that's what is fungible. You can split them. All right, going back to the vault, you can see that you have a consumed state now. Your 1,000 is consumed, and you have another unconsumed, which is 400 for this case now. right? So finally, we are left with only the redemption part. So what do we do? Now my friend has, so to redeem it, let's go to the friend node. Basically, I'll log out from here and I'll log in as the friend. Let me just revalidate what the port is. This 10,013. Yeah. Use one and test as always. There you go. We are at the friends node, and you could see that the vault he has 6,000 tokens, which was transferred to him by the buyer. And we can try and redeem these tokens now. Let's go to redeem. Redeem HSE. And who was the issuer? Issuer is still the seller. Remember that we had the token was itself transferred to us by buyer, while the issuer is still the seller. The token was actually issued by the seller. And let's say I want to probably just redeem 400 of it. I have 600, and let me try and redeem 400. And that's it. This is successful. So what you could see here is we had 600. Well, 400 of that has been burned, and I'm just left with 200. So that's how you redeem your tokens. In a real world case, that would normally be a delivery versus payment, a DVP transaction where you would receive something back for redemption. But yeah, for the sake of an example, or just to explain how redemption works, this is how it really does. You really do. You just call the redemption flow. All right. And then, or you can then again just use the query flow to check the balance. That's 200. You had 600 earlier. That's how it works. Well, basically, that gives you a very good high-level understanding of how the different flows of the token SDK are put together and how they work. Okay, so coming back to the slide now. So that's what I wanted to show you. These are all the different inbuilt flows that are there, which makes life of developers a lot easier. You don't have to write down a lot of code with respect to tokens. When you want to really deal with tokens, we have done a lot of hard work for you guys. We do have all these different kind of flows which are already inbuilt into the token SDK, and you could readily utilize them in your applications. So just to reiterate on these things, we have flows for create and issue. Now, everything also has an handler. Or what does that handler does? So handler, if you remember, every flow has a responder part to it, right? The responder flow is where your counterparty node, where the code for the execution of flow of your counterparty is written. The handlers are responder flows. So for create, you have the create evolvable token and then create evolvable token handler. Similarly, for issue, you have the issue token handler. But for move and redeem, you have two different variations of them, one for the fungible and the other for the non-fungible tokens. Similar is the case for redeem. And finally, you also have something called as the update evolvable token. So like we said, evolvable token needs to evolve over time, which means it will change. So we need to have an easy way basically of how to take care of those updates, right? So we have update evolvable token workflow, which will take care of that. And then obviously the responder for that is update evolvable token handler. Yep, that's pretty much from the token SDK. And if you want to try it yourself, we have certain samples available in our samples repository. And we have two different sample repository. One is the Java one. And if you're interested in Kotlin, we also have a Kotlin sample for you, repository for you. Just go down to the tokens folder, and you'll find pretty much 3 to 4 different token samples that you could utilize, starting from something very simple, which is the fungible house token, which I just showed you, to something a bit more complicated like the stock paid dividend or the bike market thing. So feel free to just go ahead and try those out and see how it works for you. And just one other note that I want to make here is if you go to the samples, we have just added a new feature in here into the samples repository. Now you can just directly click on the try web IDE, or basically just let me show this one because this is the one which I showed as an examples. Just click on that, and what it will do is it'll open up a web IDE instance with that particular sample preloaded, and you could just go ahead and play around with it. You could try out, you could change the code, you could run it and see how it works. So basically you have all the workflows and the contracts all available in here. You could play around, you could experiment with it. You don't have to go through the entire setup if you just want to have a look at how it's going to work, right? So this just eases out things a little bit. All right. So yep. Finally, before I say goodbye, I would just like to point you guys to the training.corda.net, which is our free training site. It is a very well done sort of. It provides you a very good flow of training where you could start with what is blockchain, and then you could learn about different concepts of Corda. And there is also a separate section for tokens, which you might be interested in after this particular webinar. So feel free, just go down to training.corda.net and get a feel of it yourself. If you want to contact us or you want to talk to other community developers, sign into slack.corda.net. It's a public Slack, or it's open to all, and anyone could join and interact. It's already a community of around 8,500 Corda developers. Very good place to be at if you're a Corda developer. I would highly recommend you to join Slack if you are there. And then you want to learn anything about Corda, we have the documentation at docs.corda.net. Obviously, you want to look at the code. It's github.com/Corda. We are developers. We want to look at the code. So Corda is open source. So just feel free to check out the code of the platform. You want to email us at devrel@r3.com. We are also available in the Slack, but just in case you want to email anything. You want to tweet, the handles are, or the official handles are Corda blockchain and inside R3. And don't forget to use the hashtags #Corda and #R3. YouTube channel, you probably know that already, YouTube/Corda blockchain. All right, that's it for today. I don't think there are any more questions. Just let me scan through them. Yep, I guess Neha did a great job of answering all the questions that were there. Yep, I think it's time for me to say goodbye to you guys. Thank you so much for joining us today, and I hope it was a great session for you. We really enjoyed doing this, and we'll keep trying to bring up new topics for you guys going forward in the future. All right, thank you so much for everyone who has joined, and have a good day, and we will meet you in the next webinar. Thank you so much.